Okay, we are back from break and ready to continue on and finish up what we're going to do today. All right, so programming. What we saw before was that how the computer works. We said, well, it has those simple instructions. We know how it works. It's a relatively simple thing. It has a very small number of components. It's got memory. It's got a processor. It's got some wires that connect the memory and the processor together. And then it's got some special memory that peripheral devices like the monitor and the keyboard and the mouse and the hard drive connect to. Now, the instructions for it, for that processor, are really simple things that we could do ourselves. So if you look over here, for example, this move A, I'm using the $sign to represent address, which is the number of a box. So this is saying move whatever's in address 10 into register A. This is saying add to register A the number 1. This is saying move whatever's in register A, or move, actually these are backwards, but move the contents of register A to address 11. Those should be switched around because it's always to and from. And on the live editing here again, let me fix that real quick. So it's right in the document. This is what I get for writing these late at night. Okay, so this is move the contents of, this is to and from, move from register A to address 11. And the CPU can only carry out those simple instructions. That's all it does. It doesn't really even know what's coming or what went before. It just says, I was told to do this simple thing. I will do that. I was told to add 1 to that thing, that one of my registers. I'll do that. And really, it doesn't even think that. It just does it. And one of the things about that, though, is we could program the CPU using that really low-level, simplistic way of doing it, but that could be tedious, could be difficult for a number of reasons. First, we'd have to know what address does what, and we'd have to keep track of all of that ourselves. We have to know that, for example, back in this program, why address 10? Is that the keyboard? Is that the mouse? Is that the monitor? We'd have to know what the point of that address was and what it was doing. And we would have to keep all of that in our head. We'd have to understand all that. The second thing we'd have to know is like all the CPU instructions and how to use them. So for example, these are pretty simple, but we'd have to know, like, okay, move this to A. And really, there is no MOV command. It's just a number that's stored in memory. So we'd probably have to know those. We have to know what codes make up what instructions. We'd have to know what characters were what numbers. So for example, 65 is a capital A. We'd have to know that. Space is 32. 33 is an exclamation mark. We'd have to kind of remember all that stuff and keep it in our heads in order to write simple programs. And it might take a lot of those simple instructions to do something useful. So for example, you think of like a game or even a simple game like Pac-Man. How many of those little low-level instructions would you have to write to make it so that you could make a game, even a simple game? And then if you think of something more complicated, I don't know, like Skyrim or something like that, think of how many of those simple instructions like this, move, add, move, how many of those would it take to do something really complicated like that? And it would be a lot of them. And so the CPU instructions, fortunately for us, you can program using that. That's kind of the native language of the processor. There are times when it's useful to do that, but in this class, we're not going to do that. There's an easier way to do it rather than programming in stuff that looks like this. And that is using a programming language, specifically a high-level programming language. And what a high-level programming language is, it's basically, well, let's look at some examples first. Some examples of that are things you've probably heard of. Maybe you've even programmed in some of these: Java, C, C++, JavaScript, Pascal, Fortran, Perl, Ruby. A whole mess of different programming languages. Go is a new one, newish one, Nim. There's just tons and tons of programming languages out there. Lisp, Prolog. So what are programming languages and how do they work? And essentially all a programming language is, it's just a special program that somebody's already written for us. And what it does is it translates from code that we're going to write in essentially a text file into the low-level instructions for the CPU to execute. So here's the special program. This would be like the programming language program. we feed it a file that we write, and it converts it into the instructions for us. So we don't have to know how all of these things work anymore or know what's in memory where. We just have to write what we want this to do in something that's a little more English-like. And so, for example, this simple set of instructions here might expand to a whole lot of different things happening over here. But the program, the high-level programming language, is going to do that conversion for us. Okay, there's kind of two main ways that programming languages are implemented. One is called a compiler. One is called an interpreter. So let's just take a second to look at those. So a compiler is basically a special program, and what it does is it translates from the source code, going back and looking at that, from the source code into the machine code for the processor. And it does that all at once. So in other words, we give it a program, it converts the whole thing into executable machine code that's now ready to run. So it's a lot like translating a book. Here's a book in one language, go through and read the whole thing, turn it into that other language, and then save off that new book or that new book in that new language. Now, an interpreter works this kind of the same, but it's also a little bit different in that what an interpreter does is rather than taking the entire thing and translating it all at once, it reads a line from the source code, translates it into CPU actions that happen right then. So rather than saving it off as the CPU instructions that are saved in like an executable file, it basically reads the program and makes the CPU do things on its behalf or on your behalf as it goes through your program. So that's kind of like a language translator who's listening to one language and translating it to another language on the fly. So you look at like the something like the UN, where they have a language translator listening to somebody talk another language and then speaking that into a microphone as the person is saying it. And that really is the same thing. Ultimately, it starts with a source code, and it's a special program that converts the source code into actions that the CPU takes. The only difference is one of them in the compiler, it saves off the machine code instructions in a separate file and then executes them. And in this one, it just takes actions as it goes through them. But it's really the same concept and the same process. All right, so the language that we're going to use in this class is Python. And Python is a very high-level language. A little bit of history here. I'm not going to spend a lot of time on its history. It was created in 1991 by Guido van Rossum, who originally created it. He named it Python because he was a fan of Monty Python, the British kind of comedy group. And he was sitting there, he created this programming language. He's like, I don't know what to call it. I'll call it Python because I like Monty Python. And you'll see a lot of, if you go through the Python documentation, you'll see references to that and nods to that. Like the little development environment that comes with it is Idle, named after Eric Idle, the one of the members of Monty Python. You also see references in the sample code to like cheese and Spam and eggs and bacon and stuff like that. Those are references to skits in Monty Python, and that's kind of stayed in there. But Python is a very high-level language, higher than C, C++, Java, other languages like that. It's also more English language-like, meaning that it's less cryptic. It's a little bit, you look at Python and it looks a little more like what it is that it's doing. It can still be a little bit cryptic at times, depending on how it's written, but it's not as cryptic as something like C that uses a whole lot of weird symbols and things like that as part of its code. And it's also an interpreted language, meaning that it reads the lines, runs them kind of one at a time in a Python interpreter program. Now, that said, the job of a programming language is to make it easier for the programmer to get the computer to do stuff. So the idea is that you want a programming language that makes it really easy for you to take your idea, write the code to feed to the compiler and interpreter to have it get the computer to do stuff for you. And along those lines, it's supposed to bridge the gap between what you want the computer to do and what the computer needs to do, the instructions that need to happen to make that computer do something. So here's the concept: is you have some kind of idea as the programmer, and you're going to write that into the source code that then gets fed into, in our case, the Python interpreter. And then that's going to carry out actions in the CPU for us. It's going to make the CPU do things for us then that's going to result in something happening in our case, in our game, in our program. And so what we are going to be doing is notice that from the programmer's point of view, he's only going to be, or she's only going to be, writing this code here and then feeding it into the Python interpreter. We don't have to worry about what's going on in the computer over here, but we are going to then look at the output and say, did it do what I wanted it to do? If it didn't, then we're going to change the source code and then run it through the interpreter again. And the cool thing about a high-level language is notice that looking at this code that's over here right now, print game, print over, even as a non-programmer who's never looked at that before, I could probably ask my mother what that does, and she'd say, I don't know, probably prints game and then prints over. And so you notice that it looks more English-like. It represents kind of what it is it's doing. But if I showed somebody this and said move, and then a bunch of addresses and a bunch of numbers, and so what do you think that does? And I have no idea. And even a programmer might take time to figure that out. And that's why we're using those high-level languages, is it kind of bridges that gap from idea to getting the computer to take actions on our behalf and lets us write those in kind of this more abstract, more English-like, more understandable format of the high-level language. Okay, now there are a whole lot of languages. Why are we using Python in this class? We'll just quickly go through some of those reasons. The first thing is that it's easy to use, meaning that it's easier to get started with. It has a shallower learning curve than other languages, and it's closer to English than a lot of other programming languages. It also tends to be a little bit more compact in the way that you can write code. In other words, you could write a program in Python that's very short, but also very powerful. And programs will typically be between 5 and 10 times shorter than a similar program or a program that does the same thing written in C++ or Java. And Python has this kind of motto, simple is beautiful, meaning that it has a relatively small footprint of instructions and keywords and kind of constructs to use, but it also is very powerful even though it's simple. Speaking of that, powerful, has all of the power and expressivity of any modern programming language. It's very expressive, very capable, has ability to do things with graphics and network programming and multi-threading and multiprocessing and file I/O and GUI and 3D graphics and 2D graphics and sound file processing and statistics kind of functionality. So there's just tons of stuff that it can do. Artificial intelligence. There's just tons and tons of things that Python can do, just like any other programming language. In other words, it's not a toy language. It's not a language just to learn programming in. It's a real language that also happens to be simple and fairly easy to get started with. Okay, a couple other things for why Python. It integrates well with other languages. So for example, it's very easy to make calls to C and C++ programs from Python. It's very easy to make calls to things like the Windows API or other APIs, other people's libraries from Python. It can compile the Java, it can compile the JavaScript. You can also embed Python into other languages and other projects. For example, the scripting language for other projects and other products, Python is one of the options for that, like Maya, kind of a 3D modeling and animation tool, has Python as one of the ways you can script things that happen in that program. And so it's easy to use it both embedding it in another project or embed things from another language into Python programs themselves. It's also cross-platform, meaning that any machine with a Python interpreter can run programs that you write. And the interpreters exist for a whole range of different things: Mac, Windows, Linux, embedded systems like microcontrollers, like Android, OS X. There are Python interpreters for all of those different things. And the other cool thing is that the programs, as long as you aren't using any kind of extension libraries that are platform specific, most of the programs are machine independent and platform independent, meaning that if you write a program and run it on Windows, that same program will run and work on Linux or Mac without you having to change a lot of stuff around on it, or maybe in most cases change anything. All right, a few more of these. It's community owned, meaning it's not owned by a company like Microsoft or Oracle. And that is, for me, important. I'll tell you why here in just a second. But it has, since it's community owned and not corporate owned, that means that there's a large community that has tutorials and users groups and forums and mailing lists, and all of that stuff is owned by the community, owned and controlled by the community, not like by a company or by Big Brother. And new versions and new features are even driven by a community process, that if you want to say, hey, I'd like Python to have this extra feature that it doesn't have right now, you can actually submit a proposal, it'll get debated, and then the committee, that's a community elected committee, will decide on whether to add that to the new version of Python or not. Another important thing, it's free. And it's free in a couple of ways. It's free as in beer, and it's also free as in speech. Now, what's the distinction between those two? Well, free as in beer means it doesn't cost anything. That means you can get it for free. Free as in speech means you're free to do whatever you want with it. There aren't any restrictions on how you can use it or what you can do. And in fact, it's all open source, meaning that if you want to take the Python interpreter and write your own version of that or modify it to do something for a project, there's nothing that stops you from doing that. So it's not like a proprietary piece of software that you're, if, for example, if you find a bug in Python interpreter, you can download the source code and fix it yourself. And you have access to every bit and every piece of the way that thing is implemented and the way it works if you want to. The other thing about it being community owned and free which is important, and that last bullet point there of, well, first off, it'll never cost a dime, never. It doesn't cost anything, and it never will. But it also will never be killed off, meaning that there have been programming languages in the past that were company created and company owned, and they decided to kill them off and get rid of them, even though they were popular and widely used. And Python, that can't really happen too. And specifically, I'm looking at you, Microsoft. The Microsoft has taken programming environments and programming languages, and they decided it didn't fit their strategy, so let's get rid of it. Let's kill it off. And they've done that with several different languages and several different platforms. Python, that can't happen with, and that's important. All right, a couple other things about Python. It's very widely used. Who uses it? Google. When you search for something on Google, a lot of the kind of Google Grid, the kind of back-end stuff is done in Python. Google at one point, they're starting to migrate to some other languages that they've created themselves, but they used to have this motto like Python where possible, C language where necessary. And so they tried to do as much as they could in Python because it has all of those features. But other companies use that as well. Microsoft, Amazon, IBM, NASA, Industrial Light and Magic, which is kind of George Lucas's special effects company that does all the special effects for the Star Wars movies. They use their whole render farm is driven by Python. Disney Feature Animation uses Python for their render farms as well. Electronic Arts, Activision, just tons and tons of companies that use Python for things. So what can you do with it? Pretty much anything. AI, deep learning, Google's deep learning kind of AI frameworks are all Python. You interact with those through Python. Same thing for Facebook's deep learning and AI stuff. But scripting, web applications, desktop applications, just about anything you can think of, you can write in Python. It has been used in commercial games and commercial game tools. Battlefield 2, Battlefield 2142, Oblivion, EVE Online. I don't know if that's still a thing or if people still play that or not. The Sid Meier's Civilization 4 is Python. Sims 4 is Python. That Disney Toontown Online. The Pirates of the Caribbean Online. There's just tons and tons of things that it's used for in games. And a couple other things, really the last thing about this here, is it's a really useful language to know if you're looking to get a job as well. IEEE, which is kind of the trade group for engineers, ranks Python as the #1 programming language this year in 2020. And considering it hasn't been around as long as a lot of those other languages, it's remarkable that it's the #1 programming language by them. The TIOBE index, which also ranks programming languages, ranks it as #3 just slightly behind Java and C. So it's a highly marketable skill to have, and in recent years it's become kind of more explosive. It's been around for quite a while, but recently it's become kind of this really useful thing to learn. And part of the reason is because it is so expressive and so powerful, and you can write code in a much smaller amount of code than it would take in something like, say, Java or C++. It's also not anything at all like a toy language. It's very powerful, very expressive. Okay, so how do you get Python? If you go to python.org, you can download it. And if you go to python.org, it'll have a download button right on the front page. I think they're at like 3.8.5 or something, or 3.8.6 or something like that. I don't know what version they're on. But just get the most recent version that's linked to there, and then install it on your machine. If you have a Mac, you can install it. If you have a Linux distribution, you can install it. If you have a Windows machine, you can download it and install it. So you'll click on that, download it, and just go through the installation process. Once you've installed it, it'll install kind of a couple different programs, one of which is the integrated development environment called IDLE, which is a really basic IDE. It's not designed to be something that professional coders code in, but it's designed to be something you download Python, edit code, run the code, test it. There are some other options that are better and more professional, and we'll look at those later on in the class. But for right now, just download it, Python, run idle, and then you can play along with the things that we're going to do. So if you want to pause the video and download that and install it, then feel free to do that, and then continue on after that. Okay, so continuing on, if you run idle, it'll come up in what's called shell mode or immediate mode. And you can tell that that's the mode it's in because you'll get a little prompt like this, and you'll have a window on the screen. You'll see a little prompt that looks like greater than, greater than, greater than. That's prompting you to type something in. So you can type in Python instructions right into the Python interpreter, the Python shell prompt, and then you can see what the interpreter does with that. All right, so let's try a few. And rather than doing that live, let's just look at them on the screen here and talk through them. So if you type print, quote, hello, quotes, those are double quotes, end parenthesis, it'll just say hello back to you. So notice this is a sign that this is an interpreted language, that when you say do this thing, it takes that one line and it takes it and then it carries it out and it does it right then. We didn't have to click compile. We didn't have to do anything other than essentially say print, quote, hello, quote, and then it says hello back to us. Now, a couple other examples here. Print 12, it prints out the number 12. Print 12 in quotes, prints out the number 12. Notice those look like the same output, but the command was different. But if I take that number version, I say print 12 plus 2, I get 14. So it did the calculation for me. So the interpreter is smart enough to know that when I say a number plus sign another number, that I want to do addition. Now remember, behind the scenes, the processor is having to have the number 12 loaded into a register, the number 2 loaded into a register, being told to add those two together, getting the results of that addition is 14, and then having to move all of those characters out to the screen in some form of a 1 and a 4. So there's a lot of stuff going on behind the scenes, but notice we didn't have to worry about any of what the processor's doing. We just say print out 12 plus 2, and it'll say 14 for us. Now, moving on to that next one, we are saying print 12 plus 2, but we left it in double quotes. Now in that case, it printed out exactly 12 plus 2. So the double quotes are our way of saying this is a sequence of characters that I want you to print or represent. But if I leave those off, it treats them as numbers. So these 12, this is the number 12 plus the number 2. This is the sequence of characters 1, 2 plus sign 2. Now if I say print quote 12 plus quote 2, notice we get 1, 2, 2. Now that's a little bit interesting, but what's happening there is we're saying take this sequence of characters 1, 2, should do it on this side, take this sequence of characters, just the character 2, and plus sign in that case means just concatenate them or stick the two sequences together to make a new sequence, 1, 2, 2. So notice that that's But notice that we're not having to worry about the processor or the instructions. We can just write these things. So we kind of have to know how to put these things together to get the result we want. And the way we do that is that each line of Python is would be considered like a statement. And so a statement will usually have some sort of command, and it'll have data that goes with that command. So in our case, like print hello, the kind of statement or the command part of that statement is print, and then the hello is what we want it to print. So that's telling the Python interpreter to invoke the print function command, and then pass data to it, give it the data that we want printed, which is the sequence of characters, the string hello, in quotes. So this is a state. So you can think of a statement, a programming language statement, like an English sentence. It's like a command to somebody. You go over there. You go to the store. Go home. So those things are, notice it's very much like that. Print this thing. So the command part of that statement, you can kind of think of it like a verb, like go. You go do this. And then the data part is like the this that you want it to do. You go do this thing, or you go to this place. So the data is kind of like how that verb is to be used, but notice it's a lot like a sentence. So the command says what we want the interpreter to do. The data provides additional information for the command for how we want it to do it or what we want it to do it to, and things like that. So it's just like English instructions. So in English, you give a command like say goodbye. In Python, you'd say print goodbye. So very much like English. Okay, now what happens though, just like in English, you can make a mistake and give somebody a bad instruction or something that they don't understand. We could do the same thing in Python. So what happens when you make a mistake? So here's a couple examples of mistakes or errors. So if I misspell print and put primt, then it's going to give me, the interpreter is going to say, I don't know what that means. So notice it will give this thing called a traceback, which will show information about where the error was, and then it'll show what was the error. So it'll give us feedback saying that's a name error. I don't know what primt is. It's not defined. That's not something I know. And just like if I have a person and I give them an instruction, instead of like go to the store, if I misspeak and I say Gorb to the store, they're going to be like, what's Gorb? I don't know. That doesn't make any sense. So same thing, the interpreter will say, tell us when there's an error and when it doesn't understand what we told it to do. Notice the same thing can happen with other kinds of errors. Like if I said print 12 plus, that doesn't make any sense because to add, you need to have two things you're adding together. So I can't just say, what's the result of 12 plus? And the interpreter will say, well, it's invalid. I don't know what you're trying to add because you didn't give me another piece of data. So for plus to work, it has to be between two things. And here I had one thing, so it says invalid syntax. Okay, other examples of errors, just going down through here. That first one. And actually, let me see if I can bring up a Python shell here. We can try these. So I'll put this in front of that. Oops. I'll put this in front of that, and we're just going to try these and see what they do. Let me do. Okay, so we're down here at this prompt, and I don't know if you can see that or not, but we're going to try these. So print quote hello, but I'm going to leave off that end quote. Notice that gives a syntax error, and it says EOL stands for end of line. It says end of line while scanning string literal. That means it was looking through this kind of string, the sequence of characters, and it got to the end of the line without finding the close quote. So it gives us an error that says that. Now the next one, print hello plus 12. Now that gives us an error, and it says you can only concatenate a string to a string. In other words, you're not allowed to try to add, if I'm trying to add a number to a sequence of characters, it doesn't know if we want to do arithmetic addition or if we want to do string concatenation. It's telling us, hey, you had a string and you tried to add a number to that. That doesn't make any sense. And so it gave us this error. It's a type error in this case because I tried to use the plus operator on two types that are incompatible with each other. The next one, all caps print hello. Name error, print is not defined. And that's an important thing. Notice that Python is case sensitive. Print is lowercase print. If we capitalize it or we just put capital P, also not defined. So it's important to know that we need to get those things right. And then the last one, hello print, that's obviously wrong. And print hello without the parentheses, that'll give us an error. Let's just try that one. It says missing parentheses and call the print. Did you mean hello? So notice in this case, it gave us a helpful suggestion. It said, hey, you forgot to put parentheses on that. You probably meant to do this over here. Okay, so back to our presentation. So to learn to use Python, we're going to have to learn those commands and what data to pass to those commands, or how the commands use that information. So we're going to also but that's really not the hard part about programming. That's especially with a language like Python. It has a relatively small set of structures, a relatively small number of keywords to learn, meaning commands to learn. The hard part is really how do we combine those instructions to make something that does what we want it to do or something useful. And so we're going to, rather than thinking of Python programs as just being one line at a time like these things, we're going to think of them as a collection of lines. This one happens, and then this, and then this, and then this, and then this. And that's how we're going to make programs that are useful. Okay, so learning Python is going to be a little bit like learning English to make sentences. And then once we know how to make those sentences, and we know a certain number of, have a certain vocabulary, we know a certain number of verbs, we know what they mean, then we're going to combine those to write a story. And the cool thing, though, about the stories that we're going to write is we can take those stories out of our head and put them into the computer in Python, and it's going to do stuff. Stuff is going to actually happen. So it's taking our ideas, putting them into the machine in the Python program, and then the interpreter is going to run all that for us, and it's going to make stuff happen in that thing. And that's going to result in games that come out of our head and then do things in the computer. And that, to me, is a really magical, cool thing. So next class, what we're going to do is we're going to dig in and learn more Python commands and start expanding our vocabulary and looking at how do we get it to do stuff. And we're going to spend a little bit of time in the shell mode, the immediate mode, typing things in, seeing what happens, looking at that. But then we're also going to start going into program mode where we actually can write a program that actually, rather than writing a line and having it do it, we can save off a script of a whole bunch of lines and give it to the interpreter all at once, and it'll run all of them and do more complicated things. So that's it for today. Everybody stay safe. And next class, we're going to dig into learning more Python stuff. We're going to have our first assignment next week. But remember what I said halfway through today, that be ready for a quiz on binary numbers and hexadecimal numbers and conversions. And you might also take a look at that stuff with the names for the different sizes of things like that we had talked about previously. Okay, so that's it for today, and everybody stay safe.